I'm thinking some of this stuff is review, but we'll talk through it anyway here. So inverse of a function, basically what it means there, I closed my book on the actual definition in the back of the book, but what you're going to do is basically you just take your x coordinates and your y coordinates and switch them around with each other, okay? So when we do that, so like thinking of our normal checking to see if something's a function rules, typically we do the vertical line test, right, of our original function. Since we're taking and doing the inverse of it, that's basically kind of like flipping whatever our graph is around. So kind of like in this picture here, like this is our original one, this is the inverse of it. What you would do to see if the inverse is a function on the original, if you can't get a graph of it, is instead of doing the vertical line test, you could do the horizontal line test on the original one, always the original one, and then that would tell you if the inverse is going to be a function or not, okay? Or if you can graph the inverse, if you can figure out how to do that, then you can use the vertical line test on that as well. But if there's some graph that you can't do on your calculator or whatever, or get a graph of, you can always take your original and do a horizontal line test on it, meaning like, you know, if it's something like this, it's crossing that in two spots at once, or if it's vertical line test on that one, crossing two spots at once there, okay? Our inverses are always going to be reflections of each other over the y equals x line. So the y equals x line is just going through 0, 0 there, and then the line has a slope of 1 because there's like nothing with the x, which means it would be 1. So your graphs are always going to flip over that line if they're inverses of each other. Okay, so let's take a look at some in our example packet then. So we'll look at the first two, and then we'll write some notation stuff with the inverses. So for our first one here, it says let H be the set 1, 1, 2, 4, 3, 9, 4, 16, and then it wants us to start by describing the inverse of that. Okay, so inverse, like I said before, just switching your x and y values around. So like the first one there for A, 1, 1, well if we switch 1, 1 around, isn't it still just 1, 1? Yeah, so that one will stay 1, 1. But then the next one there, basically we're just taking those two numbers and switching them around with each other. So like the 4 would then be the x, and the 2 would be the y. And then the 9 switches to the front, 3 to the back, 16 to the front, 4 to the back. So if it's just ordered pairs like that, it's just as simple as flipping those around. And then it wants to know for part B, is the inverse of that a function? How do we tell if it's a function if it's just a list of numbers? What are we looking for? What I typically look for is I look at my first value there and see if any of those values are being repeated, because if they're being repeated, then it wouldn't pass the vertical line test. So looking through there, if we've got a 1, 4, 9, and 16, are any of those the same number? No. So since those are all different numbers, that means they're paired with all different y values. So yes, that would be a function. And if you wanted to put that reasoning down there, you could put like no repeats of the first coordinate. Okay. And then for part C, it wants us to describe H, so our original function there, and then its inverse in words. Looking at those ordered pairs there, what do you think we would do to get from like 1 to 1, 2 to 4, 3 to 9, 4 to 16? What's the pattern those are following? Squaring, right? So if we took our x value there and squared it, wouldn't we get our y value for all those? Yeah, so the pattern that it's following there, or like describing it, you could just say H is the squaring function. Because you're just taking your x values and squaring it. Now if we do the inverse of that, which is h to the power of -1 there, which will, that's the next thing we're going to write is the notation stuff. That means inverse. What would the inverse be then if the original is the squaring function? What's the opposite of that? The square root function, right? Because if we do these ones, if we square root 4, don't we get 2? Square root 9, we get 3. Square root 16, we get 4. So it's the square root function. And then because this is kicking out all the positives, it's the positive version of the square root function. So I would say is the positive square root function. Because all of those were positive, and when we do square roots, we have to consider the negatives as well. All right, so that's the first example. next example then, describe the graph of the function y is equal to whatever there. So what I would do is I just take that and graph it on my calculator, so that way we can get our description of it. So we got 2 parentheses x plus 5 power of 2 minus 1. Just getting that graphed, and of course I got it in the wrong zoom here. Okay, so that's what I'm getting for the first one. So when it says like describe it, we could draw like a little picture of what's going on here if you wanted to. I'm going to do it in different colors here since we're going to do the inverse as well. So I'm going to do my function here. So it's something where it looks like it's kind of like a parabola slid to the right, or slid to the left, and then slid down a little bit. So it'd probably be helpful if we knew what that minimum value was. How do we find the minimum?
With the calculator.
Yeah, yes, with the calculator. So we would go second trace, minimum, and then left bound, just make sure your cursor's on the left side. Right bound, just make sure your cursor's on the right side, enter, and it tells me that my minimum value there is -5, -1. So then for part A, when it wants us to describe that function, how could we describe that? What's that shape called when it's the U shape? Parabola. So it would be a parabola, or we could say the graph is a parabola. How does it open? Opens up. So you could say opens up with, and then I would reference our minimum point here. So I would say with minimum -5, -1 would probably be enough to do a description there. So I'd graph it and then just come up with a general description. Okay, and then part B of that, it wants us to give the inverse of that original equation there. Okay, so when we do inverse of this, what's happening with our equation? What's switching around? The y and the x, right? Yep, so basically you're just gonna, in the y spot, you just put an x. So x is equal to 2 parentheses, and then in the x spot you put the y plus 5 to the power of 2 minus 1. And then technically that's just the inverse there. So if it just said, hey, give the inverse, like it's cool with that. But since it also is going to want us to graph it down here and like describe if it's an inverse from the graph or whatever, we're going to probably want to solve this for y, so that way we can put it into our calculator and graph it, right? So here, if I'm going to solve this for y, I'll just do it off to the side. Yeah, I'll do it underneath here. Okay, so if I got to solve for y, I'd probably add 1 to each side to start. So I'd have x plus 1 is equal to 2 parentheses y plus 5 to the power of 2. Then I would take everything and I would divide it by 2. So then I'd have x plus 1 divided by 2 is equal to y plus 5 squared. Then I would get rid of my squaring by square rooting on each side. And when I square root, what do I have to put over here with the square root? What kind of answers can I have? Plus or minus, right? Because again, I have positives and negative answers here, so I have to have the plus or minus, otherwise I'm not getting the full graph of that. So then I'll be down to y plus 5 is equal to plus or minus square root of x plus 1 divided by 2. And then last step, to get rid of that add 5, I'd subtract 5. So my final answer here for what I can plug in the calculator then is y is equal to, let's go, I'm going to go -5 plus or minus square root of x plus 1 divided by 2. So now that that's solved for y, now I can put that into my calculator. I think there are, from what I could figure out from online, there is a way you can graph x is equal to numbers, but you can only do it in numbers. You can't plug a y value in there. So like if you started with that equation, if it was just x equals a number, you can graph it, but I couldn't find a way to type the y value in without it giving me an error, so I'm not sure that you can graph it without getting it into y equals on the calculators. Now, if you do it on Desmos, like the online graphing calculator thing, you can type that one in and it will graph that. It will do the solving out for you, okay? So if you want to check it like later and you can't figure it out on the calculator, you can use Desmos to do that too. But now that we've got this solved out here, we can type this in. The only other thing that I couldn't figure out how to do is how to put plus or minus into the calculator. I'm not sure if there's like a button to do it or something. So what I did is I just typed it in as 2 separate equations, and I'll kind of show you. So I went like -5 plus and then that's square root of x plus 1 divided by 2. Graph that. And then what that does is it just gives me part of my parabola there, so you can kind of see that that's like the upper half of it. And then to get the bottom half of it, that's when you type in the other one. So if I type that same equation again, but do it minus this time instead of plus, square root x plus 1 divided by 2, that should give me the bottom half of that. And looking at those, you're like, well, this one seems a little bit wider than this one. The reason is because your screen is rectangular, so it's 10 by 10 here still, but because your screen is rectangular, these ones, for the x values, they're more spaced out than the ones for the y values are. If you want it to look more like realistic, like it's supposed to look, there's a button on here called zoom, and then z square. If you go to z square, it'll make your graph look more like square versus like rectangle on your calculator, and it'll make those parabolas look like they're actually supposed to look, where they're both like kind of that same skinny shape. So it just does it the other way because it's a rectangle on the screen. So if you need it to kind of switch there, that's what you would do. So then for our inverse function, when we're going to graph that one out, I'm just going to do it on the same little picture here. So that's the one where it's kind of like going like that, and going like that, same shape. If this is the inverse of the minimum point here, what would this point end up being? -1, -5, because the inverse would just switch those points around as well. So -1, -5 for your inverse point there, for like, it's not really like a maximum or minimum, it's more just like the leftmost point. But then you would just say that out for part C. So give the equation for that. It's either that equation for part B or that equation. And then part C, based on your answer to part A, graph it, the inverse of it, and then is it a function? So would this one be a function? No, it would not be a function. So it says, I guess it says describe the graph of the inverse, so we'll do this describing first. So we can say the graph is still a parabola, because it's just turned to the side, is a parabola. How does this one open? To the right, yep, so you could just say opens to the right. And then here, like I said, it's not really a minimum or maximum value, but you would probably still want to establish what that point is. So you could just say like the leftmost point. So like the leftmost point is -1, -5. And then for is it an inverse, or is the inverse a function? That would be no, because it wouldn't pass the vertical line test, or your original would not pass the horizontal line test. So that's how they're getting no for that. Alright? Okay. Back to our other sheet then. So there's some notation stuff then. So get that notation stuff jotted down there, and then we'll talk through that. And then there's a couple more examples. Like I said, I'm not sure if we'll get through all of it today, because example 4 is going to take a lot of writing. But we'll get through as much as we can, so we have less to do tomorrow. harder today than it usually is. So, oh no, she doesn't have a class 5th hour, so it can't be. Yeah, she's got my 5th hour prep. She's got my 5th hour prep. Now I have 2nd hour prep.
That's the worst.
Yeah. Although I'm more focused in the morning than I would be in the afternoon, so. Plus, like, there was something I didn't have done for this class today that I was able to do this morning instead of figuring out yesterday. So. Yeah. Okay, so let's kind of talk through this stuff. So like I said, this first thing here is just notation stuff. So when they're talking about the inverse of function f, they use that like power of -1 there, and then it's just read f inverse. When you do this though, it's not truly like to the power of -1, so it's not like it would take that number and like flip it to the bottom or whatever. It's not meaning reciprocal there, that's just the notation for it, okay? So it's not saying take whatever it is to the power of -1, it's just a notation thing, which is kind of confusing. I don't know why they do that, but it's just what it is. And then our steps for finding inverse, this is very similar to what we did on that last one. They just add in there that like if it's f of x or g of x, you just put the y in there instead, because obviously you can't switch an x and a y around if you don't even have a y. So put that y in there first, then solve your new equation for y, and then once it's solved for y, then you can just put your f and then that -1 there, or f inverse and g inverse in there instead. Okay, and let's try to get through example 3 here. I think we can get through example 3, and then we'll just leave the rest for tomorrow. So example 3 is kind of similar to the last one, where we're just taking an equation, finding the inverse, and then doing some stuff with it. So it says, give the equation for the inverse of the function with the equation y is equal to 5 divided by x plus 8 minus 1. So again, when we do inverses, we're just taking our x and y and flipping them around. So like x would equal 5 over y plus 8 minus 1. And then again there, for us to be able to graph it, what I would do is I would solve that for the y. So here I would add 1 to each side. So x plus 1 is equal to 5 over y plus 8. And then when you've got that y on the bottom, to get it to the top, what you have to do is you have to take this whole equation here times that whole chunk that's on the bottom, because the plus 8 is currently attached to the y. So you think of that as a chunk. And to get it to the top, you've got to multiply by that whole chunk of y plus 8. Because they're kind of hooked together because it was divided by both of those numbers. Okay, because then if it was multiply and divide there, those cancel. Gets us just down to a 5. And then now we've got on this side, it's y plus 8 times x plus 1. And I would leave it as 2 chunks versus actually foiling that out, because we need to get rid of this full chunk of x plus 1. So to get rid of multiplying by that full chunk, I would divide by that full chunk of x plus 1 on each side. Because then with that gone, you're left with y plus 8 is equal to 5 over x plus 1. And then last step to get rid of the add 8, just subtract 8. So then one that you could put in your graphing calculator would be y is equal to 5 over x plus 1 minus 8. And then they just want to know if it's a function or not. So again, what I would do is I just do it on the calculator. It's the easiest way. So if you want to see the original one, you can also type that one in. So like 5 divided by parentheses x plus 8 minus 1 is the original. And then the new one would be 5 divided by x plus 1 minus 8. So that's our original. And then that's our new one. And then what you can look at here to confirm that they're inverses of each other, they should always be reflections over that y equals x line. So if I had a line going through there, doesn't that look like it would reflect over and be the same thing? Yeah, so that confirms that we did the inverse part right. And then with that second picture, if we do vertical line test on that or horizontal line test on the first one, would it be a function? Yeah, it would be. So the answer for part B would just be yes. Should be a function. Okay? All right, we'll be done with that. I don't have my watch today, so you'll have to tell me when it's time to go. Usually I let you out at 12:04.